Hello everybody, I am Aditya from Texas A&M University. In this video, I am going to demonstrate the working of the CPP to CXX framework. The principles behind the process of demacrofication has been explained in our previous paper, Rejuvenating C++ Programs through Demacrofication. The working of the CPP to CXX framework can be explained with the help of a flowchart. To carry out the task of demacrofication, the CPP to CXX framework takes old C++ programs and generates a new source code by removing the macros. It is a set of three tools. The CPP to CXX suggest tool performs a set of analysis to collect relevant information and generates possible C++11 declaration for the macros. It also generates intermediate files, which is used by the CPP to CXX validate tool. In order to evaluate the correctness of each suggestion, the CPP to CXX validate tool introduces one macro at a time into the software and rebuilds to verify whether the refactoring would preserve the build. It generates a list of all the macros which could successfully be introduced into the software in a special header file defined.h. To generate a program which has macros replaced with language declarations, the CPP to CXX finalize tool uses the header file define.h and generates new program which would compile correctly. Now I am going to demonstrate the working of the tools with the help of a sample project that has macro usage. So first of all, we will run the CPP to CXX suggest tool. This tool takes as input a config file that has to be configured for each project. So after this tool completes its execution, it generates intermediate files in a special directory d_dir. So as we can see that for the macros for which the tool provides a possible alternative has been guarded within a conditional with the help of a unique macro switch. For function like macros, we have a possible function declaration as an alternative. For the function like macro that are inside of a function, we cannot have a function declaration as a possible alternative. So the tool provides a lambda function declaration as a possible refactoring. Now after this, we can run the CPP to CXX validate tool. This tool can be run in three different modes. For this demonstration, I have configured the tool to run in the no suggest mode. So this tool introduces one macro at a time into the software and verifies whether the refactoring would compile correctly or not. For all the macros that produce correct refactorings are listed in a special header file define.h. Now after the validate tool completes its execution, we can run the CPP to CXX finalize tool. This tool has the same backend as the CPP to CXX suggest tool and uses the same config file as input. So after this tool completes its execution, it generates the rejuvenated source code in a special directory dm_cleanup. So we can see that for the macros for which the possible alternative were correct are replaced with the C++11 declaration, and for those macros for which the possible alternative was not correct, or the macros for which the tool couldn't provide an alternative, are preserved in its original form. The formatting of the source code is modified because we supply a new possible declaration for the macros. Now we can copy the rejuvenated source code into the project directory and then we can compile to see if it compiles correctly. So it compiles perfectly fine, but now we are getting a warning message that we're not getting previously. This is because this macro has been replaced with a C++ declaration and the compiler can verify that this variable is not used. This completes the tutorial of this tool. Thank you very much.